Well, hello guys, here Mr. G with another question for the grade 10s. This time we're going to be solving a question on electric circuit. This was question 8 from June 2013, done at the Northern Cape at set A. But before we start, subscribe for the channel so you can get all the notifications and videos I post on regular basis. Anyway, this question says that refer to the circuit diagram below. A battery is connected to 3 identical resistors with resistance of 2 ohm. The reading on the voltmeter is 18 ohm and on the ammeter is 5 amperes. Okay, that is the circuit you have here. What is the terminal potential difference for the circuit, for the above circuit diagram in which current is flowing? And guys, remember the terminal potential difference is the EMF, or is the potential difference of the battery when the circuit is working, when the circuit is closed like this one. So the terminal potential difference for this question here is going to be 18 volts. That is the terminal potential difference of the circuit. Question 8.2. 900 joules of energy is released when 300 coulombs of charge move through R2, okay, in 100 seconds. So R2 is this one here, this one here on this side, this one is R2, and they want to calculate the potential difference there. Now for this question, let's write the data and let's do it right here. This one will be question 8.2.1. okay, so let's write data here. What is given to us? They say that 900 joules of energy. So energy with the symbol is E, or in this work here, in these things we are doing, could be also W, is going to be equal to 900 joules. Okay, that is given to us, is released when 300 coulomb of charge. So the charge, I'm going to write capital Q. Remember, it could be also a small q, is equal to 300 coulombs, and then move through resistor 1 in 100 seconds. So the time is equal to 100 seconds, and they want to know what is the potential difference there. So the potential difference in that resistor. Guys, let's go to the formula, which are just here below. So the formulas that we are going to see for electric circuits are here. Okay, and look here guys, potential difference, which is this one here, this formula is for potential difference. That formula there is for potential difference, guys. Okay, and this one is the one we are going to use in this specific question here. So if you write the formula here, potential difference is equal to W, which remember W is the energy we are talking about, divided by charge, and all we have to do is to substitute. So W is 900 and the charge is 300. So potential difference is going to be equal to 3 volts. That is the answer for potential difference of R2. It is quite simple. I hope you understand. If we go to question 8.2.2, the current in R2. So using the same data, now question 8.2.2, using the same data, we're not going to rewrite it. We are going to calculate the current. So current is capital I, and let's go to the formulas, guys. Also, again, here we're going to the formulas to see which one we can use for a current, and it is right here on the left side. This here is for current, right? And we have all the data for that specific formula. So we go back there and then we write the formula. Current is equal to charge divided by time, that is rate of flow of charge, is how you read that formula. So current is equal to charge, which is 300 divided by 100, which is the time, and this will give you 3 amperes. There we go. and that is the current, guys. The current is equal to 3 amperes. We having the current for R2. That is question 8.2.2. Now, if we go to question 8.3, determine the following for R3 and give a reason in each case. Now, for R3, now we are talking about this resistor here. This one is R3. Okay, first they're asking you for the potential difference. Now, these two resistors, R2 and R3, are connected in parallel. The current here is coming and is splitting in two parts. It's going there and there. That is why these connections, they are in parallel, and therefore here at the end is coming all the way together again. So those two connections are in parallel. You need to remember that in a parallel connection, the potential difference is going to be the same. So the potential difference of R2 will be equal to the potential difference of R3, and in this case is going to be 3 volts. So the potential difference for R3 is going to be equal to 3 volts. For R3 is equal to 3 volts. That is the answer. And the current, now the current is a different story. It's going to divide, it's going to spread, but because the resistors are the same, remember the current is not necessarily the same, but in this question, only in this question, because the resistors are the same, 2 and 2, then the current is going to spread equally. So if we have 3 amperes for this side, 3 amperes for that side, the total is 6, you can see there, then 3 is going to go also here. But now how can we do it in case they are not the same? Well, we have the total 1. You need to know that in that side, I'm going to do it here, the total current is going to be equal to the current that is going on the 2 resistor plus the current that is going on the 3 resistor. Okay, that's all you have to do in this situation here. Therefore, the total current, which is going to be 6, is going to be equal to 3 plus the current in the resistor 3, and guys, this one is equal to 6 minus 3. So current is equal to 3 amperes. This is not needed because the resistors are the same. That is why if you come here to the question, they say determine the following. Okay, that is the current, which is equal to 3 amperes. So that is quite simple, guys. That is quite simple. This is how to determine the current. The potential difference, not much to do because they are in parallel. But that is question 8.4. Calculate the equivalent resistance for R2 and R3. In other words, they're asking you to calculate the resistor in parallel. We can do it on this side here. They're asking you to calculate the resistors in parallel. Let's do it here at the bottom here. So this one is question 8.4.1. Alright, so how do we calculate the resistors in parallel there? Guys, let's go back here. Let's not make mistakes. Here is the formulas. Now, we have 2 formulas for resistor in parallel. One is this one here. This one is for R parallel. I'm going to do parallel like this. If you follow what I'm saying, you understand. And this one can also be used, but this one is, look here, this is a quite important statement there. So you can only use that one if you have 2 resistors, which is the case. But we're not going to use that one. We're not going to use that one because that one is very easy. Let's use this one. We can make you a little bit more confused. But what I want to show you is that the formulas are here. Okay? So we go there and we know that now 1 divided by the resistor in parallel, I'm going to write Rp, is equal to 1 divided by R1 plus 1 divided by R2. In this case, it's not R1 and 2. Let's use it would be R2 and R3, okay? Because those are the resistors in parallel there. So it's R2 on this side here and R3 on this side here. And when you substitute here, we'll have that is 1/2 plus half. That is the question here, because each resistor have a resistance of 2. You can see it there. Okay, so that is the one there. When you substitute this one will give you 1. Now, what I want you to be careful is that the resistance in parallel is not 1. 1 divided by resistance in parallel is equal to 1, which is not the question. So to solve this one now, you have to say, you may use your calculator, that the resistance in parallel is equal to 1 to the power minus 1. So whatever answer you get on this side here, you are going to say to power minus 1. Which obvious in this case, because it is 1, then the answer is going to be 1. But I want you to know that whatever answer you get on this side, guys, it must come to the negative 1. This one is quite simple because the answer is 1. Therefore, it means that R in parallel is equal to 1 ohm. That is not the total resistance, that is the resistance for the parallel circuit. Now, in question 8.4.2, in question 8.4.2, they ask you to calculate the total resistance of the circuit, the equivalent resistance of the circuit. Now, how do we calculate that one? This formula is not given. This one is the addition of the resistance in series plus the resistance in parallel. That's all. It's very, very simple. So what is the resistance in series in this specific circuit? That one will be R1, which is there. So it is 2. And then the resistor in series that we calculated was 1. So it's 2 plus 1. Therefore, the R total, which is the equivalent resistance of the circuit in this case, is going to be equal to 3 ohm. That is the answer for 8.4.2. Very simple and good questions, this one here. The following question refers to the resistance in an electric circuit. Now, the first is to explain what is resistance. That is the question 8.5.1. So let's do it here, 8.5.1. They ask you, as we said, explain what resistance is in a circuit. So we can say that the resistance is the opposition to the flow of electric charge. Very simple. And question 8.5.2 explain one factor that affects the resistance of a substance. Now, there is a video I posted quite long ago, one of my first videos related to factors affecting the resistance. So there are few factors I'm going to mention, but you have to explain only one of them. So we go here, question 8.5.2, factors. Now let's mention those factors real fast. Now the first factors I'm going to speak about all of them, but you don't have to. You can only mention one. It's going to be temperature. Temperature is the first factor that you have to remember that can affect the resistance of the conductor. Alright, so what we have to say, the higher the temperature, the faster the particles will move. Now, when they say the faster the particles will move, we are referring to the particles inside the material. We are not referring to the electric charge. The particles in the material start moving up and down. And then that will present a higher resistance to the flow of electric charge. There is a video on this one, guys. I will leave the link. The second factor we are going to speak about is the type of materials. Now, in this case, the different materials will have different resistance. That have to do with the spaces between the particles. How far are the particles from each other within that specific material and so on. Okay, but you don't have to say all that. The third one is length. So you need to know that the longer the conductor, the higher the resistance. And the last one, guys, is the thickness. The thickness of the conductor. So now, the thicker the material, the more space will be for the electrons to flow, the charge to flow, therefore the less the resistance. So guys, these are the 4 factors. You don't have to mention all of them in this question. This question is asking only for one factor. Alright, explain one factor. However, they are all of them. Question 5.8.3. Give a macroscopic description of resistance in a circuit. Refer in your answer to electrons, particle, and kinetic energy. Okay, so let's quickly do that explanation. There is also a video where I explain that one there. But let me just do a small drawing here. This here is a conductor, for instance, okay? And inside the conductor, there are particles. You learned that inside any substance, there are particles. So there is lot of particles, okay? Now you also learn that those particles are moving. So I'm going to write particles moving. They are moving all the time. Now electric charge or electric current is the flow of charge. So let's say electrons want now to pass by that specific material. So these are electrons, and those electrons has to go through the material, guys. But you can see that there's a lot of particles, so those electrons are going to be bouncing through the particles, so it have to get a way to pass through. All right, the more difficult it is to pass through, the higher the resistance. So this is what is going to happen. And then if it's coming another electron, remember we are not talking about only one electron, there are many electrons to come, they are passing through. But you can see these particles, they're static, but it's not real like that. These particles are moving all the time. So this is a microscopic description of what is actually happening there, guys. So this is what is happening, but you have to say it in words. The higher the kinetic energy of the particles, I'm talking about the particles within the materials, the higher the resistance. The particle will move more with inside the circuit, and the particles, the electrons, will struggle to pass by. That is all you have to say, but you have to say it in words, guys. So let's perhaps write the answer right here at the bottom. Okay, guys, so this is all we have to say. When electrons move in a circuit, they collide with the particles. During this collision, kinetic energy is transferred from electrons to particles. But this is the microscopic picture of what is actually happening there. And the final part of this question, explain why a battery in a circuit goes flat eventually by referring to energy transformation. Is very, very simple. And then this is going to be the end of this video here. Alright, so what do we have to say here? That electrons moving from the battery into the circuit possess potential energy. This converted to kinetic energy as they move, and this kinetic energy is further on converted into another type of energy, like for instance heat or light or those things. Eventually the battery will get flat because all the potential energy was converted. Guys, in grade 12 there is going to be a chapter that will explain everything you need to know about cells. Okay, but guys, this is the question. I hope it helped. If it helped, thumb up, subscribe for the channel. I'll see you next time. Mr. G here.